Give an equation that satisfies the units for watts, volts, and amps. So that is power is your watts, your voltage, and then your amps. The reason I've done that is because when you're given a question in an exam, you're often only given sort of units. They're not going to say thing, oh, the power of this is that and the voltage is this. Sometimes they'll just say a device of such and such watts, and you need to know that you're dealing with power there and volts, and you're dealing with, that you just need to know this stuff, which is why I've put this in. So here's a little question. What current, which is I, flows through a 2.6 kilowatt electric fire? Well, see, it hasn't given me a power there. So I just got to know that now wattage is to do with power. And it's a kilowatt as well. Electric fire at a potential difference of 230. So if I do the triangle, so let me just show you where. So in an exam, I would be looking now at a equation that satisfies that. And I would be going for this one by here, PVI. Because I got voltage, I got current, and I got power. Okay, and that's the one I'd be using. And it's a good way to stick that into a triangle. If they're together, VI, and there's nothing between them, it just means that they're timesed. So that's V times I. And if they're together, then P has to go up. Okay, something like this one, where V is already on top of R, V just stays at the top then. And you can put that in a triangle like that. But if they're together like that, then P always goes up. So it's going to be P over I times V there. So let me get my thingy back, and I pull that back. And then I can do my little, I'm going to change my color as well to black. And then I can just do a little triangle, which I haven't done. So it's P, I, V, V, I. And then if I cover I, I've got P over V. And that's what I've got going on by here. So I've written out what I know. P equals 2.6 kilowatts. Now, again, a kilowatt is equal to 1,000 watts. So I need to convert this into watts now, because this is what we're dealing with. We're dealing with watts, not a kilowatt or anything else. So 2.6, we multiply now. So 2.6, because we're going from big back down to small. Whereas the other one, I was going from small to big. So 2.6 kilowatts is equal to 2,600 watts. My voltage is 230, which is standard, really. It's always going to be 230 for our main supply. What's my current? Well, I've done the calculation there. I equals P over V, because I've used my triangle. I've replaced my values. Here it is, 11.3 amps. What fuse value would be the best use for this fire? I haven't done it for some reason, but it's going to be a 13 amp. I'll tell you straight now. 13 amps. There it is. And then we start getting on. So let's do this, because this is a bit of an add-on, really. How do you know if an appliance you are about to buy is efficient or not? Well, on these things is an energy efficient rating chart. And the very energy efficient ratings equal the lower running costs. So these are usually band A's and then you've got band G, which are not very efficient. And there'll usually be some sort of diagram or a chart that you can get off that. It's a bit of they've just added it onto the spec just at the end. I don't know why, but it might come in there. We'll have a look. Probably in another video or exam style questions, this is more relevant. But I want to get back to this now. So this is all about paying for electricity now. I think I've covered. Let me do one more question that kind of goes with the other ones. It's what type of circuit do you have in the house to plug the devices into? Well, the ring main is a parallel circuit. And the advantages of that is that sockets can be placed anywhere, and they'll always be 230 volts. Remember, in parallel, the voltage stays the same. And then there's two paths to the current, so cables can be thinner. So because there's two paths, and I haven't got a picture of a ring main circuit here, but there's two paths. So voltage can be pushed on the one, and then the other one can be the blue wire can send the current back. So that means that the cables can be thinner to carry so they're carrying half the current really. There we are. So less current is carried in each cable. So that's that one. So I think I've done that. Describe how cost and electricity is calculated. Include. So this one now, I mean, if we look down by here, we've got this one. Units used equals power times time, and then we got cost, units used times cost per unit. And usually you'd have to work out the units used before you can calculate the cost. And the other thing to notice, and it's a big clue here, this one is already in kilowatt hours, kilowatts. So this time, when we look at these ones now, we're going to be dealing in kilowatts. So I'm going to go to the Jenny question. If Jenny gets ready in the morning by having a shower for 10 minutes, so I know my T now is 10 minutes, and then dries her hair using 150 watt hairdryer, taking another 30 minutes, how much energy has she used? So she uses the shower, which is 3 kilowatts, so the power for 10 minutes, and then she uses the hairdryer for 30 minutes. How much energy has she used? Well, the energy we can say as a kilowatt hour in this case, can't we? So units used, and we're going back to that. I can get that from there. Units used, look. So it's all there ready for you. The time is in hours, and the power is in kilowatts on this occasion. So the time is in minutes, so I need to convert that to hours. And I need to convert this to hours. This one is easily, is more easily converted into, it's a late night, more easily converted into hours than this one. Okay, so with that one, because it's 60 minutes in an hour, I've done the equation in 1 over 60. So this one comes out to be 0.0167 there. So units used, so the power for the first one is 3 times, so 3 kilowatt hours is already there, times 0.167. Sorry, I said 0 there, but that's what it is. That comes out to be 0.5 kilowatt hours. Okay, just for the first one. And then the second one, because we add them together, units used is going to be 0.5, because it's half of an hour. So it's 0.5 of an hour, times 0.75 kilowatts. What have we done there? Oh, sorry, 1.5 there, because that I convert that to a kilowatt. Sorry, I had to think what I did there, and that becomes 0.75 kilowatt hours. So that is that bit there. How much energy is she used? And now it's going to want the cost now. So when I add these two together, so I'm adding this one together, 0.5 plus 0.75, and I get 1.25 kilowatt hours. And then if it costs 16 pence per unit of energy, how much does it cost to get ready? Well, we got this equation again here. So cost equals the units used, which I just worked out, times the cost per unit. And it tells me the cost per unit in the question. And the cost per unit is 16 pence, so I've just times 16 by 1.25 there. Gives me 20 pence. Okay, not a lot really for going out, 20 pence cost. Done that box, I've done that box. Okay, we're getting there. Describe how the cost of electricity is calculated. Include the units necessary. This probably would have been a better question to come to first before going on to this one up here. But there we are. So the cost equals units used times cost per unit. And I get my units used from calculating the energy transferred, really, which is units used equals power times time. Okay? It's just energy. Energy equals power times time. And it's just a different version. But we've got to keep it in kilowatts and hours. That's the big thing with this one. This one needs to be kept, and I'll do it in green, kilowatt hours and kilowatts and hours. There we are. I've done that box. And then I think the last box I need to do before I come to the 20-minute mark, so this will be 2 videos, is an iron is used for 1.5 hours and has a power rating of 2.3 kilowatts. If the price per units, this is just wrapped up in one. So first of all, I'm going to have to find out the units used by using 1.5 hours times the 2.3 kilowatts. This is a nice easy question because it's there. So yeah, this would have been a nice question to do before the big one over here. So units used, power times time, 2.3 kilowatts times 1.5. Really easy there because that's already in hours. This one's already in kilowatts. That comes out to 3.545 kilowatt hours. And then to calculate the cost, I'm just using that cost equals units used times cost per unit. And if the cost per unit is 40.6, it's 3.45, which I got from there, times 14.6. It's going to be 50.37 pence. And that is, I think, we've covered everything there. Albeit I've taken my, I probably confused you on this one, going straight into that. But this one was just the hardest. So if you stuck with me, if you stuck with the video, then this one would make a lot more sense if we did it last. But I'm not going to redo the video again. Just not. It's not happening. And yeah, this bit we will. I mean, you need to do past papers questions to really understand this. Okay, I'll leave it there.